Hey everyone, in this video we're going to be looking at another 5 hard SAT math questions and their solutions. I pulled these questions directly from the SAT Suite educator tool for the question bank off of the College Board website. So we're going to be looking at the hard level questions, specifically the advanced math topic. So this first question, we have this equation that's got some absolute values and it's asking us what's the positive solution to the given equation. So when we're talking about the solution to the equation, we're talking about the variable or unknown, which is x in this case. And since we've got absolute value, it's asking us what is the positive solution. Okay, so a couple of ways that you could go about this. If your algebra is really fast and you know this well, then I'd say the fastest way is actually just solve this directly for x. But we'll talk about some other ways you can do it too. So when we have 2 of this quantity, 4 minus x, and we have another 3 of this same quantity, 4 minus x, it combines to 5 of that same quantity. So we have 2, we have 3, so now we actually have 5 4 minus x's, right? Because that 4 minus x, that quantity in brackets, it's really like the same thing. They're just like fancy brackets, right? Except the absolute value is going to turn whatever we have inside of that. If it is negative, it'll become positive, right? So it's just kind of like a special quantity. And this is equal to 25. If we divide 5 out from both sides, then we are left with the quantity of absolute value 4 minus x is equal to 25 divided by 5 is 5. And from here, we know, okay, if x is any value that is less than 4, then whatever's going to be inside the absolute value will already be positive, right? Try that out. 4 minus 4 is going to be 0, but if you plug in something less than that, 4 minus 3, it's positive 1. 4 minus 2 is positive 2. Keep going lower and lower until we even get into the negatives. It's still going to be positive. So it means that when x is less than 4, that means that 4 minus x is going to just be left as positive value, because 4 minus x, we can drop our absolute value signs and just treat it as 4 minus x is equal to 5. Okay? But when x is greater than 4, well then in our absolute value sign, it becomes a negative value, and we know that the absolute value, it has to turn something positive, right? Because we only care about the magnitude of it. So what's really happening here is it's actually going to be negative 4 minus x. Our absolute value becomes minus times 4 minus x, because we know that this is going to be negative. And to make it positive, we can just multiply it all by negative. So this is going to be equal to 5. And now we have 2 super easy equations that we can solve, right? From this first one, we can move 5 to the other side. 4 minus 5 plus x to both sides, and we get x. And we get negative 1 is equal to x. In this other case scenario here, let's multiply both sides by negative 1. 4 minus x is minus 5. Okay, let's move the 5 over to the left side. Plus 5 to both sides, plus x to both sides. We're left with x is 4 plus 5, or x is equal to 9. Obviously, I was doing a lot of explaining here, but you can do this very quickly. If you understand absolute value, this is super fast, easy to plug in and solve for x. Another way that you could do this, say that you're not so sharp on your absolute values. Well, if you have access to Desmos, let's bring this over here. Okay, well, we notice, actually, before we look at our Desmos, notice here, look at this equation. We've got, from very limited understanding of absolute values, we can see that we get the equation 4 minus x is equal to 5. If you can even just get as far as there, right? It's just asking us what value of x. Let's do, so absolute value of 4 minus x we get this function here. And when does this equal 5? And specifically, y equals 5. And we can see here, we get the same values of x if it equals 5 at both x equals -1 and at x equals 9, right? Which is exactly what we solved for. It's asking us for our positive solution to the equation. So x equals 9 is our positive solution, right? Both ways, very fast. Depends what your preference is. Let's move to the next question. We get this quadratic equation, and it says one solution to the given equation can be written as 1 plus the square root of k, where k is a constant. What is the value of k? Okay. For this one's a little bit more algebra heavy. Doesn't look like we can do any graphing here. If you can, I would love to see a comment. One way that you'd want to approach this, okay, first thing that we notice, it says that one solution is 1 plus root k. So that's telling us that we know that x is equal to 1 plus the square root of k. This is one solution. So we've got this quadratic. Ideally, what we'd like to do is kind of separate this second degree term and our first degree term, so we just have like a single x value to the first degree. That way we can more easily solve for x, right? Because it's telling us that it's in the form of 1 plus the square root of k, right? So, okay, one way we could do this pretty quickly, x squared minus 2x minus 9. Okay, we know this is equal to 0. Okay, x squared minus 2x. If we were to turn this into a perfect quadratic or a perfect binomial, I forget what the term is, but we can just do +1 and then -1 from this. You can see here, if we just group that, we can see that this is a binomial, just x minus 1 squared, right? If I can add 1 to this equation as long as I subtract 1 right after. That's fine. I'm not doing anything game changer. If I +1 and I -1, it's just that you're adding 0, just making it look different. So now that means that we're left with x minus 1 squared -1 minus 9 is -10. This is 0. And look at this. We're already left with x minus 1 squared is equal to 10. Square root both sides. We get x minus 1 is square root of 10. Say plus or minus the square root of 10. And then we get x is equal to 1 plus or minus square root of 10. Right? So 1 plus square root of 10. We know x is in the form of 1 plus square root k, which means that k is going to be 10 in this case. Okay, so our answer is B. Okay, let's see. Maybe there's another way that you'd wanted to solve this. Okay, we know that, okay, let's do option B here. Okay, another way that, if we know that x is equal to 1 plus square root of k, right, it takes this form, and we have the equation of x squared minus 2x plus or minus 9 is equal to 0. Well, then we can just plug in our value of x that we know is a solution and then solve for k, right? If we, this is just a quadratic of one variable, and x is 1 plus square root of k. That's also just one variable. If I make a substitution here, it should just turn into a new quadratic that we can solve directly for k. So we can see we get 1 plus square root k squared minus 2 times 1 plus square root k. Minus 9 is 0. Quick little math here. We get 1 plus 2 root k plus k minus 2 root k minus 9 equals 0. Our minus 2 root k cancels out our 2 root k. And then we've got k is left on this side. If we move the 9 to the other side, the 2 to the other side, that's 11. And we've got minus 1. So this just becomes 9 plus 2 minus 1, which is 10. So it tells us right there, k is equal to 10. Another way that we could solve this question. Another way that you might think of solving this is that, well, we have our quadratic, x squared minus 2x minus 9. Why don't I just solve this thing directly? If I solve it in exact form, I should be left with something that I can make look like 1 plus the square root of some kind of constant. So you could try that too. So let's try that as well. Option C, okay, we know x is equal to, okay, minus b is minus negative 2 plus or minus the square root of b squared, which is going to be 4 minus 4ac. A is 1, c is negative 9. All of that over 2a, where a is 1. Okay, this way we're going to be left with 2 plus or minus square root of 4 plus 36 all over 2. Then we're left with 2 plus or minus square root of 40 over 2. And this, well, we know that that's 2 over 2 plus or minus half times the square root of 40. Square root of 40, well, that's just 4 times 10. Okay, and we know that, right, square root of 4 times the square root of 10, right, is the same thing as the square root of 4 times 10, right? Which means that this is 2 times the square root of 10. And then we're left with 2 over 2 is 1 plus or minus, and then we've got 2 root 10. This is divided by 2. This is 1 plus or minus square root of 10. We're left with 1 plus square root 10. We can see that k is equal to 10. This one's a little bit uglier. So when it comes down to looking at all three of the different ways that we can solve this, right? Either turning it into this, like we complete our square, we get this perfect binomial, and then we can solve it like that. I'd say this way, if your mind goes to it, probably the easiest in terms of algebra. I would say this one's also pretty fast. Option B, it's a little bit more intuitive because we know that 1 plus square root k is our solution. So it's a little bit more work to get there, but also shouldn't take you that long. I would say option C, it works, but it is a little bit tougher to think of, like, we got to reduce our radical. We have to do a little bit more manipulation on our end. We have to rely a bit more on our algebraic ability to get us into the form of 1 plus the square root of k. So I would probably suggest solving it with method B, and because I don't think that method A here is necessarily the most intuitive way that a lot of people would think of solving it. So either A or B. Again, all of these work. It's just however the fastest way it is for you to solve it. And that might depend on how you think. So let's move to the next question. It says, in the xy plane, a line with the equation 2y equals 4.5 intersects a parabola at exactly one point. If the parabola has equation y equals minus 4x squared plus bx, where b is a positive constant, what's the value of b? Okay. If you have Desmos available to you, this one was quite simple. So we know that we have, okay, 2y is equal to 4.5, right? That is right, yeah. 2y is equal to, yeah, 4.5, or y is 2.25. And then we've got our downward shaping parabola. Okay, downward shaping parabola here. And that's going to be in the form of y equals minus 4x squared plus bx. We're at a, oh, wrong. No, no, no. And this is plus b times x. And we've got our slider b is, minus 4x squared plus b. It's asking us if it intersects at one point, what's the value of b? Well, you can see if we change our slider here, you can see how this parabola moves, how it intersects with our line. We're looking at when it intersects at just one point. It looks like it intersects at the one point here. When our slider is set to b equals 6, that's 1 point. And then you'll notice that there's also another point. If we move it to this side, we get also minus 6 as well. It intersects at just 1 point, right? But the question tells us where b is a positive constant. So if you have access to Desmos, pretty clear to see that, well, b is going to be equal to positive 6 when it intersects at just 1 point. Okay? But a lot of the time, we don't get access to Desmos. It is a bit of a luxury to have a graphing calculator, especially one as powerful as Desmos. If we don't have that, well, what can we do? Okay. Well, we're looking for when does the line minus 4x squared plus bx, when is this going to be equal to 2.25? 2.25 because we know 2y is 4.5, so y is 2.25, right? When does this happen? And now we really just have a quadratic, right? We have minus 4x squared plus bx minus 2.25 equals 0. If it only intersects at one value, we know our discriminant, which is b squared minus 4ac, is going to be equal to 0 because it has 1 point of intersection, right? Or one intersection with that line, 2.25, right? I guess when we're looking at this discriminant, oftentimes you kind of think of it as like the roots of the roots of the equation, right? But in this case, since we started off with the equation minus 4x squared plus bx is 2.25, well, when we set this to one side, the roots of this equation is just the solutions. And the solutions is that point of intersection, right? So that's why don't get confused when we think points of intersection and roots. Our discriminant here, the roots of our equation is our solution. And our solution is that point of intersection with 2.25. I hope that makes sense. So we have b squared minus 4 times, well, a is minus 4, c is minus 2.25, and this wants to be equal to 0. Okay, do this math, we get b squared, this is going to be minus, okay, we got 16 times 2 plus a quarter of 16, so that's going to be 32 plus another 4, that's 36. Or just, if your mental math's not great, calculator, and there you go. B squared is 36, and we get b is equal to plus or minus 6 by taking the square root of both sides. B is going to be our positive value here. B is equal to positive 6. So yeah, if you have access to Desmos, I'd recommend doing it that way. It's a lot faster, but definitely is great practice to do it this way as well, especially if you don't have access to it on a test. And I'll tell you right now, if you don't understand the way that we just did it, but you do understand how to do it on Desmos, you're not doing yourself any favors when you go off to college, and you're not given that ability on an evaluation. So make sure that you really fully understand it both ways. Okay, next question. We have got the first term of a sequence is 9. Each term after the first term is 4 times the preceding term. If w represents the nth term of the sequence, which equation gives w in terms of n? Okay, this one tells us that our first term is 9. So n is equal to 1, w is equal to 9. Tells us that right away, okay? Well, fastest way is honestly just see which ones of these is going to make that work. We can narrow it down quite a bit. For A, we get W is equal to, okay, for n equals 1, we get 4 times n 9 to the 1. That is not equal to 9. So it's not A. For B, we get 4 times 9 to the 1 minus 1, which is 0. 9 to the 0 is just 1, which is 4. That is not equal to 9 either. Okay. C, we get W is 9 times 4 to the 1, which is clearly not 9 as well. And last one, well, it's got to be this one. Let's just double check. W is equal to 9 times 4 to the 1 minus 1. This is 9 times 4 to the 0. 4 to the 0 is 1, and we're left with 9. So by process of elimination, we can very fast, quickly see that D is the number 1, right? This is our only possible option for the solution. It's a lot easier than trying to do this question by trying to come up with the equation yourself. You could do that as well, but it makes more sense to just, we have a value of n, we have a value of w, just plug in, see which ones work, right? It's going to be a lot faster that way. Let's move on to the next question. Okay, last but not least, we said we've got 2 equations here, okay? Number 1 and number 2. Which ordered pair is a solution to the system of equations above? Whenever we've got these roots in our equations, it's going to be a lot more annoying to plug this into a Desmos or graph it, because often they give us decimal values. They don't give us the exact value. Exact values are a lot more powerful when we can do them by hand. So with this one, we can immediately knock off B as one of our possible answers, because we know that, well, from equation 1, x should just be equal to 1 plus the y value. I can clearly see from A that x is 1 plus the y value, root 3. Same with C. And then D is a little bit more confusing, but you can also verify that that works as well. So how do we narrow it down from there? Well, it's honestly, you can either guess and check, plug in our x values and our y values and see if it satisfies both of the equations. But I see this quadratic here. It might be kind of annoying to do that. I would resort to that if you don't think that you could quickly solve this. If you do think you can quickly solve this, well, you've just saved yourself like 3 times the amount of work by trying for A, C, and then D. Because if D is the correct answer and you've already done the algebra for A and for C, then kind of annoying if you could just solve it directly and get the answer. If we know x is 1 plus y, let's just substitute it into 2. So we get 1 plus y is equal to, oh, actually, sorry, my bad. We should do, oh, no, what am I doing? Yeah, sorry. This is 1 plus y is equal to, we get 1 plus y squared minus 3. So this becomes 1 plus 2y. Expand this, we get 1 plus 2y plus y squared minus 3 on our right hand side. We can see our 2y's cancel each other out. Our 1's cancel each other out. We can move the 3 to the other side. 3 is equal to y squared, and we get y is plus or minus the square root of 3. If y is plus or minus the square root of 3, well, remember x was just 1 plus y. So that means x is either 1 plus root 3 or 1 minus root 3. We can see option A very clearly satisfies that. So option A is going to be our correct answer for this one.